So today we're going to start chapter 7, and 7.1 is called the Pythagorean theorem, and we're going to have a quiz after section 7.3. Okay, so the Pythagorean theorem, you probably remember this from earlier years, is used to find the missing sides of a right triangle. Again, it can only be used if the triangle is a right triangle. Sides A and B are called legs. So again, in this picture up here, okay, this side A and this side B are called your legs. And side C is the hypotenuse. And again, the hypotenuse is always the side directly opposite that right angle. Okay, so C is always opposite the right angle. And again, that's called the hypotenuse. So what is the Pythagorean theorem? The Pythagorean theorem is A squared plus B squared equals C squared. And then on the bottom here in red, it says, does it matter what sides are assigned to A and B? In other words, could I have named this side B and this side A? Okay, and the answer is it does not matter which one you call A and B. Why? Because you're adding here and addition is commutative. Okay, so the order doesn't matter. So no, because addition is commutative. And what that means is order doesn't matter. Okay, again, so really what does that mean? If I add 3 plus 2, if I change that order, it's 2 plus 3. Both times that you add there, you're going to get 5. So the order does not matter when you're adding. Okay, so we're going to find our values of x and round our answers to the nearest tenth. So again, in this picture, we have a missing side of a right triangle. The only thing that matters is what you are calling C. And again, C has to be the side that's directly opposite your right angle. It has to be the hypotenuse. So we'll do A squared plus B squared equals C squared. And in this case, that C is going to be x squared. And again, on the other side, it doesn't matter what you call A and B, so I'll do 8 squared plus 13 squared. Again, just make sure you're following order of operations here. We have to square the 8 and the 13 before we add. So 8 squared is 64, 13 squared is 169, and that's going to equal x squared. When I add 64 and 169, I should get an answer of 233. So 233 is going to equal x squared. And again, x still isn't by itself. And again, the opposite of squaring something is taking the square root. So you have to take the square root of both sides here. And this says round to the nearest tenth. That's going to be one spot after the decimal. So when you chuck that into the calculator, you should get an answer of 15.3. So x is going to be 15.3. One way you can sort of kind of check yourself here, that hypotenuse, C always has to be your biggest side. Okay, so if I have an 8 and a 13, my answer over here is bigger than 13. I'm pretty sure I'm on the right track. So if I had gotten a number that was less than 13, something is definitely wrong. Again, that hypotenuse has to be the biggest side of that triangle. For number 2, we want to find the missing side, and this time we're going to express our answer in simplest radical form. So again, the only thing that matters is what we call C. C has to be the hypotenuse, directly opposite that right angle. So 9 has to go in for C. The other two don't matter the order that you put them in for. So again, C, I'll put that in first. There has to be that 9 squared, and on the other side, again, it doesn't matter which one you call A and B. So I'll say x squared plus 7 squared equals 9 squared. Again, the first thing that I'm going to do here is square each of those numbers. So 7 squared is 49, and 9 squared is 81. The opposite of adding 49 is to subtract 49. And when I do that, I'm going to get an answer of 32. And again, we have to put this in simplest radical form, but still the first part of that still is going to be to take the square root of both sides. The opposite of squaring something is taking the square root. So right now, x equals the square root of 32. And again, when we're simplifying that, we are looking for the biggest perfect square that's a factor of 32. The biggest perfect square that's a factor of 32 is going to be 16. And 16 times what would give me the 32? Just divide 32 by 16. You'll get an answer of 2. And then finally, we can take that square root of 16 it's 4, and then tack on the radical 2. So 4 radical 2 is going to be your final answer there. Okay, number 3, find in simplest radical form the length of the diagonal of a square if the measure of one side is 12. So again, if you have a square, and here's its diagonal, and the measure of one side is 12, that means the other side is 12. A square has a right angle, okay, and again, I'm looking for my diagonal there, so I'll call it x. So again, now I'm just going to concentrate on this bottom triangle, and that x is going to become your hypotenuse. So a squared plus b squared equals c squared. And in this case, we'll have 12 squared plus 12 squared equals x squared. 12 squared is 144. So we'll have 144 plus 144 is going to equal x squared. And again, when I add 144 and 144, we're going to get 288. And that's going to equal x squared. Again, the opposite of squaring something is taking the square root. Again, we want simplest radical form here. So I'll first write it just as the square root of 288. Okay. So now I'm looking for the biggest perfect square that's a factor of 288. You can sort of kind of cheat right here. The fact that you are using 144 twice here is going to have to mean that 144 is a factor of 288. And it just so happens when you take that 288 and divide it by 144, you're going to get an answer of 2. Okay, so again, I can kind of see that from this step right here. If you have perfect squares here that are the same, what that perfect square is going to have to be a factor. Okay, so the square root of 144 is 12, and tack on my 2. So 12 radical 2 is going to be my final answer there. Okay, and the next one, I have a rhombus with diagonal AC has a length of 20 and BD has a length of 48. And eventually we're going to find the perimeter of our rhombus. So again, always nice to have a picture of what's going on here. So here's a picture of my rhombus. Again, it makes no difference where you put A, B, C, and D as long as they're in order clockwise or counterclockwise from wherever you start. Okay, so here's diagonal AC. And it tells me that AC is 20. So I'll put a little 20 here. And BD is 48. Okay, and eventually, again, we want to find the perimeter. So a couple things here. Okay, first of all, the diagonals of your rhombus are perpendicular. We know that from last chapter. So there's my right angle. Okay, and again, if I eventually want to find the perimeter of the rhombus, I'm going to have to find one side of the rhombus. Okay, and the other thing here is that the diagonals are bisect each other. So if the AC is 20, that means the two little pieces that make it up are going to be 10 and 10. If BD is 48, and again, we cut that in half, that's going to make this top piece 24 and the bottom piece 24. And now I can just concentrate on that purple triangle and again use my Pythagorean theorem, a squared plus b squared equals c squared. Again, my hypotenuse here is going to be my x squared, and then I'm going to have 10 squared plus 24 squared. 10 squared is 100. 24 squared is 576. So I'm going to have 100 plus 576 squared. And when you add that, you should get an answer of 676, which is going to equal x squared. Okay, and then we're going to take the square root of both sides. 676 is a perfect square. So when you chuck it into the calculator, you're not going to have to round it to anything. There is no simplest radical form here. The square root of 676 is 26. Okay, so 26 represents one side of the rhombus. We want the perimeter. The perimeter is going to equal the sum of all four sides. But again, all four sides of a rhombus are congruent. So if one is 26, all four are 26. And if I do 26 times 4, that means your final answer here, the perimeter of that rhombus, will be 104. Okay, Bob has a square picture that he is framing and placing on his wall. The poster has a diagonal that is 18 centimeters long and it fits exactly inside the frame. The width of the frame around the picture is 3 centimeters and determine the length of the side of the frame to the nearest tenth. Okay, so again, eventually what we want to do is we want to find that side that I just highlighted in purple. And again, this little piece from here to here is what they're telling you is 3. Okay, so the first thing I'm going to do is I am going to concentrate on that orange triangle right here. Okay, again, they told me it's a square picture. So again, square picture, square has a right angle. And again, the first thing that I'm going to do is I'm going to find one of the sides. So if I call that side X, the other side has to be X as well, because again, the sides of a square are congruent. So we'll start with a squared plus b squared equals c squared. And again, c is the side directly opposite my right angle. So we're going to have x squared plus x squared equals 18 squared. Okay, again, just be careful on that right-hand side. X squared plus x squared is 2x squared, and 18 squared is going to give me an answer of 324. Okay, I'll divide both sides by 2, and x squared is going to equal 162. Again, to get rid of that squared, the opposite of squaring something is taking the square root. Again, eventually I'm going to have to do this to the nearest 10th. So I'm going to put the square root of 162 into the calculator, and I'm not going to round to the nearest 10th yet. So I'm going to push it out a couple spots. So how about 12.728? So again, what that represents is, so far this green side now, we know that that's 12.728. But again, I want to find the purple side altogether. Hey, again, they told you that this piece down here was 3. Okay, and again, that means that this piece up here also has to be 3. So if I take my 3, and my value of x and add it together, that's going to give me that entire length. So we're going to do 12.728 plus 3 plus 3, and that will give you an answer of 18.3. That should be 18.7. I think I added wrong. Yeah, 18.7, sorry. 18.7 to the nearest 10th. Okay. And that's your final answer there. Last problem, an isosceles triangle has congruent sides of 20 centimeters and the base is 10. Find the height of the triangle in simplest radical form. So again, if I draw a picture of what's going on here, here's my isosceles triangle, congruent sides of 20 and 20, and the base altogether is 10. Okay, and we want to find the height in simplest radical form. So again, the height, that's the altitude. Altitude, again, perpendicular. So there's my right angle. So again, what we're going to do is we're going to concentrate on one side of my triangle. So that blue triangle that I just highlighted there. Okay, and again, not only in an isosceles triangle is your altitude perpendicular, it also bisects your base. So if this is 10, that means this piece is 5 and this piece is 5. So again, I'm looking for the height. There's my side opposite my right angle. So I'm going to do a squared plus b squared equals c squared. So again, only thing that matters is that 20 is going in for c. So I'm going to have x squared plus 5 squared equals 20 squared. Okay, so x squared plus 25 equals 400. We'll subtract 25 from both sides, and x squared is going to equal 375. And again, this is asking for simplest radical form, so we're not just going to chuck this into the calculator to take the square root. We're going to have to find the biggest perfect square that's a factor of 375. For me, I mean, I know I've been doing this a long time, but for me, something jumps out immediately with 375. Okay, if you think of 375 like money, $3.75, I can convert that to all quarters, meaning 25 cents. So that means that 25 is going to be a factor of that number. Okay, so 25 is the perfect square. That's a factor there. So when you take your 375 and divide it by 25, you'll be left with 15. Again, I can take the square root of 25. It's 5. I can't do anything with that radical 15. I'll tack that on in the end, and that's my final answer.